Welcome everybody, my name's Scott Somerville from Opera. I'm here with these two intellectual giants that are part of our scientific team. Today we're just going to do a little bit of a question and answer session around water damage and mould, and I'm probably just going to start by, look, there's lots of that work going on at the moment, so I think the key thing is just to understand what procedures are in place, what sort of instruments they use, what sort of water damage events we're used to going to. So I might just start with Curtis. Can you give me some examples of the typical water damage events that we're going to at the moment, and historically the type of water damage things that we get involved with?
Yeah, for sure. At this time, we've actually just recently had all the Brisbane floods and all down the east coast. So the majority of our work at the moment is anything from rain coming from the sky, water damage, to overland rivers and creeks rising up. We've also got overflow from contaminated sources like sewers and stormwater, those sort of sources as well. Okay,
so obviously there's a lot of claims going around. The industry's guided by a number of different standards. Can you run us through probably the standards that we're referring to when we're giving the consulting advice, and probably what the restoration industry is working with as well?
Yeah. The main standards that we refer to is a couple of industry standards: S500, which refers to water restoration, guidance on the water restoration and water damage; S520, which is for mould contamination restoration; and if you're talking about damage to air conditioning systems, which is one of our bread and butter areas, is the ERA HVAC guidelines best practice. Okay,
so Stuart, we're going out to site. We're not quite sure what we're going to see. You've got a whole lot of tools and different methodologies at your disposal. Can you just run us through some of the things that you might use on a typical inspection?
Yeah, so for the initial inspection, to determine the level of water damage, we use the moisture meter and the probe of the moisture meter to test the water contents in the building materials, whether that be the walls and floors or other building materials. There's also the microbial sampler that we use to test the air for mould and the type of mould spores, and determine whether they're above acceptable levels or not.
So Stuart, I know that this is one of our most recent purchases, the Micrometer. It's a bit of a leap forward in a bit of rapid microbiology for these types of projects, where we can give a clearance on a day straight after the work's been done. There's a little bit of bucket chemistry involved. Stuart, can you run us through the Micrometer for air and surface, and how you use it on projects?
Yeah, so the Micrometer is a really good device. It's capable of giving rapid turnaround within a few hours for air and surface swabs. It can detect the microbial activity on the surface or in the air, as compared to sending the samples away to a laboratory and waiting days for analysis results.
So if you had an enclosure similar to an asbestos enclosure and you were going to do a clearance similar to an asbestos clearance, you could go in there, get the result, then they can pull down, done all your moisture readings and everything else, and then you can give the go-ahead for rebuilding fairly quickly. Essentially,
that's what we could do. Yes, we can get those sample results within a few hours, which is really beneficial to speeding along those projects and making sure that that the contractors can move on to the next site for remediation, and they're not held up waiting for analysis results.
So Curtis, there's a few other instruments that you have here. Can you run us through both of these?
Here we have the Protometer, which is another moisture monitor. It comes with a variety of probes, similar to what Stuart was saying earlier, where it's got a probe for poking into materials and getting different moisture contents. It's also got more intrusive probes, an adaptation, and it's also got concrete slab probes, which is quite important if you've got a large layer of inundation, your slab has been quite soaked, or you've got a source of moisture underneath your slab. Drying out your slab is quite an important process before you start building back on top of it. The other piece of instrument we have here is an ATP meter, basically a surface assessment, cleanliness assessment device. Just measures the total microbial activity of a surface before you going to the next restoration step or handing back to a client.
So you can see there's a range of instrumentation there. There's a few other things, particularly around psychometrics, particularly data logging for making sure that you're getting structures dry in different environments, whether you've got windows open or it's contained. Okay, Stuart, so obviously, mould's one of the hazards with these types of jobs, but with storms and damage, with hazardous materials, asbestos roofs, what sort of things do you take into account when you're assessing a property and you see other hazards?
Yeah, so very important that prior to any remediation works happening on site, an asbestos survey needs to be undertaken to determine if there's any hazardous materials such as asbestos in those properties to avoid the exposure to the occupants or to the workers.
So Curtis, we've spoken about the instrumentations and some of the hazards. When you're preparing a scope of work, what are some of the things that you're looking at? Obviously different materials with their porosity, as to remediation, and probably the big thing during remediation is contamination control, how you contain the contaminants, how we make sure that that's happening. And what about HVAC systems? If the HVAC systems are in an infected area, how do we control the contaminants during those processes?
Yeah, so for any large restoration works, firstly, when we've identified the different contamination levels on different materials, we refer back to the standardised guidelines so that we're not just making it up as we go, it's actually an accepted guideline that we're following. Depending on the material, again, as Scott was mentioning, some materials cannot be restored. Once they get exposed to water, particularly contaminated water, it's just throw them out, remove and throw them out. And during that process, even the removal stage, there's a big emphasis that must be on the contamination control. If you've got a substance or a material that's contaminated with mould or contaminated water, you don't want that spreading, cross-contaminating to other areas. So you'll have to do things like double bagging and making sure that the contamination is encapsulated. You're working in areas that are controlled where there's no airflow moving from those contaminated zones to somewhere else. And that usually includes installing and constructing plastic walls and negative air machines that are HEPA filtered to make sure that you're not getting any of that cross-contamination from those known contaminated zones to areas that may not be.
Thanks very much, Curtis. Thanks, Stuart. I think probably one of the key things at the moment is, everyone's asking me about sampling. Should we go and what sampling should we be doing? And I think probably given the large number of events, very cautious about sampling. I think the initial assessment needs to be the removal of all the water damaged materials. Sampling should be considered if it's going to be reoccupied quickly or if you want a clearance so that they can rebuild. But given that there's a shortage of builders, a shortage of building materials, it could sit empty for 3 or 4 months. So maybe some of the clearance sampling happens now, and then it might need to be done again in 4 months just before they do the reconstruction. So every job's different depending on the need and when it's going to be reoccupied, who's going to be reoccupying it. It might be a critical area in a hospital, for example. So all of these things get taken into consideration around what we're doing sampling. We're not sampling for the sake of sampling. So it's very important that you get the project plan right. I'd just like to thank my colleagues for going through some of the materials and some of the methods that we have. Look, we're a NATA accredited laboratory for asbestos. We know our hazardous materials and mould, whether it's in structures or air conditioning systems. So if you're an insurance company, a residential or a commercial building owner, we've got the equipment and the team to be able to provide you with a solution for your water damage and mould issues. Go to our website, or give us a bell, and we'll come and have a chat with you.